Sri, am I audible? Just for the confirmation.
Yes, Devinder, you are.
Yeah, great, great. Thank you. I came across a quote which says that there are no mistakes, just learning lessons and moving on. Whether it is life or philosophy or any other branch for that matter, humans never stop to evolve. Neither in the case of science nor technology. We all can see that we are at a stage not just able to reach Mars through technological means, but also bringing up the idea of colonizing Mars, which was once considered to be impossible or just a nightmare. A very good evening to one and all present here. I am Devinder, currently pursuing my BTech in Aerospace Engineering, greeting you all on the fourth day of outreach program. I would also like to introduce Namana Siriam Gowda, who is also pursuing her BTech in Aerospace Engineering, will be accompanying us as the co-host for the day. At SSERD, we offer online courses, workshops, projects, and internships on wide range of topics related to space, astronomy, and aerospace sectors. For more information, please check out our official website. The sponsors collaborating with us today are Genex Space and The Space. Let me tell you guys a short story and a relevant one. A story on Michael Faraday, where he was once questioned by a senior politician for his discovery on electromagnetic induction. That what is the use of the discovery which you made? Faraday replied back with a clever answer that what is the use of a newborn baby? It takes time for every concept to turn into a technology. In fact, it even took a lot of time to develop aircrafts and rockets. Science always needs thrust to bring up technology. Now let us depart from the space voyage into a space rocket to get some thrust based enthusiasm by diving into the trends of rocket technology and development. On the panel, we have Gabe Gabriel, who is a former engineer at Kennedy Space Center, NASA, and Dr. Cbs Kiran, lead at R&D and strategy at Skyroot Aerospace Private Limited and a former scientist at VSSC ISRO. I'm glad to introduce the moderator for today's session, Arjun Srivatsa, who has completed his degree in BTech Mechanical with specialization in aerospace engineering. He has also written a conference paper on vibrational analysis of an aircraft landing gear system during landing. Like we all, he is also a space enthusiast. He is currently working with us on the outreach program of SSERD. Now, I request Arjun to take over the meet and introduce the speakers for the day. Arjun, over to you. Arjun, you have been
Yeah,
muted. Yeah,
yeah. Thank you, Devendra, for the introduction. I hope I'm audible right now.
yeah, you are audible.
Cool. Um, I'd like to introduce our two speakers, amazing speakers for our audience today. Our first speaker is Gabe Gabriel, who was an engineer at US Air Force and a civil structural engineer at Kennedy Space Center, NASA. He's currently a motivational speaker. He visits schools across the world and interacts with students about space, science, and exploration. He's also a member of the Disabilities Awareness and Action Working Group, where he works with people on developing solutions to obstacles for personnel with disabilities in their workplace environment. Our second speaker is Dr. Cbs Kiran. He's an expert in material characterization, transmission electron microscopy, and spectroscopy. He started out his journey with a bachelor's in metallurgy and materials technology from Mahatma Gandhi Institute of Technology, Hyderabad. And he continued his journey with master's and PhD in the same domain from the University of Kiel, Germany. He's also a scientist and engineer at the Vikram Sarabhai Space Center, ISRO, where he was responsible for the transmission electron microscopy and the spectroscopy at the Materials Characterization Division. He's currently leading the Research Development and Strategies Division at the Skyroot Aerospace, and he's also Director of Research and Development at Anantapi. He has also received numerous awards and recognitions for his achievements in applications of electron microscopy and in material sciences, and is a member of numerous scientific societies both in India and across the world. It's truly an honor to have you both in our panel today, and welcome to Outreach. Before we begin, I'd like to just talk about the series of events that we're going to have today. We're going to start with our first talk by Gabe, followed by Dr. Kiran, and right after that, we're going to open the floor for a mini panel discussion, and then we'll take in questions from the audience. Gabe, the platform's all yours.
Okay, thank you so much. I really appreciate it. Excuse me. I'd like to say good evening to everybody in India. Good morning from Cocoa Beach, Florida. It's about 8:30 in the morning here, so I know it's in the evening there, so it's a little different with the time zone. But I really want to thank Nikki and Jay. 2 years ago, I was in India at this time, and we had the most amazing time. I think I stayed about 10 days, and we went to many universities, many schools, actually spoke with tens of thousands of students. It was absolutely fantastic, and I really want to thank them. Also, I'm a big supporter of women in space, so I think this is a wonderful event. So before I start the presentation, I want to tell you a little something. Most of the time you are going to be told, in order to be successful, you must work hard. You want to do well in university, you must study hard. If you want to do well in sports, you must practice hard. Everything that you have to do it hard in order to be successful. And if you're not successful, it's because you're not doing it hard enough. Well, I don't believe that at all. My theory is have fun, enjoy what you do. I want you to think about 3 things, and I'll talk about these 3 things a little bit more as we progress. 3 things every day, all day. Do your best, enjoy what you do, and believe in yourself. If you can learn these 3 things, you will never work, you will never have stress, you will never have pressure, and you'll be very successful. And I live this way, and I like to share this with you because it's so important to me. Kids are always filled with stress and pressure and all this kind of stuff. It really isn't necessary. Your life should be fun. And if you enjoy something, you do it better. So I really want to encourage you to do that. So the first thing we're going to talk about is Mars. I'm going to start sharing the screen. So are we good now? Everybody can see the slide? Hello? Can you guys hear me?
Yes, Gabe, just a moment. I think they're trying to share the screen right now.
Okay.
Gabe, just a reminder, have you shared the screen?
Yes.
Can you share it again, please?
Yes, I'll try again.
Yeah. We can see it now.
Now you can see?
Yeah.
Okay, so this evening, I'm sorry, we'll talk a little bit about Mars and the rovers on Mars and what they're doing on Mars, how they've got there, and the future of exploring Mars. But for me, I like to talk a little bit about the space shuttle in addition to Mars, because the shuttle, I was at Kennedy Space Center for 17 years, and I probably saw about 50 shuttle launches. And it's the most amazing thing you can ever imagine. And I will explain a little bit about that, and I'm going to show you a launch as well. But one of the greatest accomplishments of the space shuttle, its primary purpose was to build the International Space Station. It was the only thing large enough and powerful enough to take the big pieces to space to build a space station. And it didn't stop flying because there was something wrong with it. It stopped flying because the mission was complete. The space station was built. But one of the things the space shuttle did, before the space shuttle program, it was only 100% men in the space program. During the Apollo missions, it was all guys. When people were going to the moon, it was all guys. But with the advent of the space shuttle program, many, many women engineers got involved. And now women in the space program do everything. They fly the orbiters, they navigate them, they maintain them. Here's a girl, her job, every time the shuttle would go up to space, it would come back down. It was completely disassembled and everything was checked. And this is a girl, her job is to put the engine back into the orbiter. She's on a forklift and she's got a handheld controller, moves the forks up and down, side to side, in and out. And she has to guide that engine into the orbiter. If she hits the engine on the side of the orbiter, she could damage the engine, damage the orbiter, create millions of dollars worth of damage, and delay the mission. So what she does is critical to the mission. It takes her 3 hours for one engine. She never makes a mistake. So it's wonderful to have women in the space program, and we really thank it to the space shuttle. When the space shuttle lifts off, it's got 3 main engines in the orbiter, and it's got 2 solid rocket boosters. Combined is 3 million kilos pushing against the Earth. And I want to show you a launch. I just want to tell you a little bit about it first. I know many of you have flown in a plane. When you fly in a plane, you get on at the passenger terminal. The plane goes on a taxiway to a runway, and it stops, and it locks the brakes, and they build up the engine, and they're building up power and building up power. When they get enough power, they take off horizontally. Well, the shuttle is doing the same thing. It's locked down on the launch pad, and they start the engines, and they build up power and build up power until it's got enough power to launch. And so when we're on the Space Center, it's amazing to see these things from the Space Center. We're about 5 kilometers away. So 5 kilometers away, you can see it. It's kind of small, and you really can't hear it, but you feel it. So what happens when they start these engine up and it's trying to take off? It's locked down on the launch pad, and it's developing all these 3 million pounds, 3 million kilos of thrust. And what happens is, all of a sudden, you can't really see it, you really can't hear it, but you feel it. You're standing there, and all of a sudden, your body starts vibrating. It's literally shaking the Earth as it's trying to take off. And it's building up power and building up power. And all the cars feel it too. So the horns are going off, lights are flashing, sirens are going off. You've got this magical sensation in the air, and then it launches. So it's just so amazing. I want to try to take you with me to the Space Center when I show you these launches. And I want you to understand the feeling and excitement. And hopefully you get a chance to see this. So this is what it's like to see a launch. So first you see at the bottom of the orbit these igniters. They're burning off any vented fumes from the tank. And then they'll start the engines. And it can't take off because it's locked down on the launch pad. But that's when all of a sudden the Earth is shaking. So you're watching this thing and you really can't see it, you really can't hear it, but you feel it. So that's steam from water. They put 3 million liters of water on the launch pad for heat and noise suppression. For the first 2 minutes, they're bouncing around quite a bit until the boosters come off, and then it gets really, really smooth. Two minutes into flight, the boosters come off. The boosters can fall off above the water. About 50 kilometers above the water, a parachute will open. The boosters fall in the water. They go out, picked up, brought back, and reused. So while SpaceX is landing them back on the launch pad, NASA's actually been, for 30 years, been collecting them and reusing them. So after the boosters fall off, the orbiter and the tank go up in orbit. The tank falls off and burns up in the atmosphere. It only takes 8.5 minutes from the time it launches to get into space. So I hope you enjoyed that. I love watching it because I relive it every time. So this is Mars. This is what Mars looks like now. It's kind of desolate, and it's kind of just a bland planet. But this is what scientists believe Mars looked like billions of years ago. They think it looked a lot like Earth. That had oceans and lakes and rivers, even had an environment like Earth. And that's one of the reasons to explore Mars. They think something may have lived on Mars at one time or may have lived there today. Now, scientists for the longest time were wondering what happened to Mars's atmosphere. They thought a great big meteorite may have crashed through the atmosphere, put a big hole, and it all escaped. But a few years ago, they came up with a different theory. We have solar storms and solar flares that come from the sun at tremendous speed, and they bounce off Earth's atmosphere, and they create all of these pretty lights, the northern lights. What our planet Earth has a strong magnetic core that protects it. The same thing with Mars, but Mars has a weak magnetic core. So I think as these solar storms and solar flares were coming at Mars over billions of years, as it was rotating, it eroded the atmosphere away to what it is today. So if you look at Mars and you look at Earth, they're what we call similar. I know many of you had geometry, you studied similar triangles. Similar means they look the same, but they're different. So if you look at Mars and you look at Earth, you can see they're similar. First of all, Mars is about 1/2 the size of Earth. Our planet Earth is spinning at 1,600 kilometers per hour. It takes 24 hours to go around one time. That's called a day. Mars is spinning at 800 kilometers per hour. It takes 24 hours and 37 minutes to go around one time. That's called a sol. And they're both tilted at the same axis. I want to tell you something about the Earth. If you haven't heard it yet, you will hear it. Somebody is going to say to you, the Earth is flat. And they're going to swear the Earth is flat. If somebody says to you, the Earth is flat, all you do is say yes and walk away. Don't waste your time trying to argue. Don't waste your time to change your mind. They just want to upset you. But we know the Earth is round. But I always like to laugh about the people who think it's flat, and they are so adamant about it. But we know the Earth is round. So, okay, let's jump on a ship and go to Mars. Well, it's not quite that simple. There's something called opposition. What opposition means are things are moving. If you're in one city in India and go to another, which I did by many different types of transportation, nothing is moving, including the traffic. We sat so much time in traffic. It was so much fun, but I really enjoyed it. But if you're on Earth and you want to go to Mars, our planet Earth is spinning at 1,600 kilometers per hour. And it's going around the sun at 110,000 kilometers per hour. It takes 365 days to go around the sun one time. That's called a year. Mars is spinning at 800 kilometers per hour. And it's going around the sun at 86,000 kilometers per hour. It takes 687 days for Mars to go around the sun. So you've got both planets spinning, going around the sun, different speeds, different orbits. You want to launch something from Earth and have it land on Mars, almost 400 million kilometers away. And one of the things I have for I'll mention this to you because a lot of friends in astronomy like to say this. So the Earth goes around the sun, takes 1 year to go around. So if you have a friend having a birthday, don't say happy birthday. Say to them, I wish you a happy trip around the sun. It's just a cool way to wish them a year ahead. So these are 3 types of rovers that have gone to Mars for the US. The first one, the one in the middle, is called Sojourner. It's a very small little rover, and it went to Mars really to test a landing system. It was going to land in a balloon type of lander, and they wanted to test it to see how it went. And it stayed on Mars. It only went about 100 meters, but it was really very, very beneficial in developing the landing system. The one on the left is called Spirit. There were 2. One was called Spirit, one was called Opportunity. And they're a little bit bigger. They're about the size of a desk in your school, and they're solar powered. These first 2 rovers are solar powered, and they went to Mars to look for water. The one on the right is called Curiosity. Now, Curiosity is much different. You can see it's much larger than the other 2, and it's nuclear powered. So we'll talk a little bit more about those 3, but I also want to mention Perseverance. Perseverance is the most recent rover to land on Mars, and it's doing amazing things. We'll talk a little bit about that as well. So for America, we've had these many missions to Mars. Phoenix went, Viking 1 and 2 were the first 2. Then it was, I believe it was after Viking 1 and 2, it was Pathfinder, which is Sojourner. Pathfinder is the name of the mission. Sojourner is the name of the rover. And then we had Phoenix. We have Insight. And Insight was really interesting for me. I was in Denmark speaking at a university when Insight landed, and it was around Christmas time. So we were at the university doing the presentation, and after the presentation, we all went to this really beautiful restaurant in Denmark. We brought our laptop with us, we sat at the middle of the table, and we watched Insight land. So that was really, really, really very special. Curiosity is on Mars functioning right now, as is Perseverance. So this is Sojourner. Sojourner, again, is a very small little rover. It only weighs about 12 kilos. It's pretty small, but it went to test a landing system that involved a balloon. So it would land in this balloon, and it would test it for future missions. It actually went around Mars. It was the first thing to put tracks on Mars. It only went about 300 meters, but it sent a lot of information back on the geology of Mars and how Mars formed to what it is today. This is Spirit. Now, Spirit had an amazing run on Mars. It lasted about 5 years. Now, Spirit is solar powered, and I'm going to show you how it got to Mars. But I want you to do something first. I want you to all pretend you're all engineers at Kennedy Space Center, or whatever your field is, you're working at Kennedy Space Center. So my job is kind of like a civil structural engineer, and it was great because normally as an engineer, you're assigned to a design team and you design facilities or you design structures, but you're part of a team. So my case was a little bit different. I was a facility programmer. So what I would do, I was responsible for roads, bridges, the infrastructure, facilities, anything that had a problem. They would say, Gabe, go find out what the problem is, figure out how to fix it and how much it costs. So what that did for me, it took me all over the Space Center, to the launch pads, to all of the cool facilities. Every day I went somewhere different and every day was magical. So when you're in a design team, you're sitting in a building and you're doing your design, and all of a sudden they would make an announcement. There's going to be a launch in 10 minutes. So we'd all put our stuff down. We go outside to see this launch, and it's super cool. You're getting paid a lot of money to be an engineer, yet you're going outside to watch the launch. And once you're outside at the launch, there's another public address system, and you'll hear engineers talking to a launch director. And they're telling each engineer is responsible for a system. So they're monitoring the system on this rocket. And when the system is good, they will tell the launch director, good, the system is good. And when all of the engineers report to the launch director would say, go for launch. So I want you to all think we're out at this, and we're by the beach, which is kind of cool. So we're out by the beach, we're watching this launch, and we're hearing all of this things talking. So one of the things we do at the beach when we're there, they count down. Every launch, they count down 10, 9, 8, and we all jump in and count down with it. So I'm going to show you a launch. This is actually a Delta launch, and it's how this mission got to Mars. So, but when you hear them counting down, I want you to count down with them. So this comes from the Jet Propulsion Laboratory in Pasadena, California. And this rover weighs about 200 kilos. That's Mars, almost 400 million kilometers from Earth. So this rover's in the nose cone. Now you're going to hear the engineers talking to the launch director.
SSC disconnect enable on. 35. Let guys go. Hydraulics go. EC pressurized vehicle locks tanks. Pressurizing. SSC hydraulic pump control on.
So I want you to count down with it.
CLCDR pad B deck flush on. On. Pressures go. 10.
9, 8, 7, 6,
Green board. 5,
4, 3, 2. We're all doing this at the beach, and then we yell blast off and we all jump up and down. We have so much fun with these launches. I hope you can share this. I want to show you how this mission got to Mars. There's 9 boosters on this rocket. When it gets to a certain speed and certain altitude, the boosters will come off.
Which program is in?
They call Earth the pretty blue planet because of all the water. So you're going to see a lot of different pieces on this mission. Each piece has a function. Some are navigation to keep it going in the right direction. Some are for propulsion to keep it go at the right speed. It's got to overcome all those variables of the planet spinning, going around the sun, different speeds, different orbits. So it's constantly adjusting. So you're going to see when it goes by the sun, you'll see the sun and all the billions of stars in our solar system. So it takes 7 months to go to Mars. Think about it. If you go to Mars, you're going to be in a spaceship for 7 months, and you've got to stay active mentally and physically. So there's a lot that goes into it. When it goes through Mars' atmosphere, even though it's thin, it still generates a lot of heat. So it has to have a heat shield to protect it. Because the atmosphere is thin, it doesn't slow down very much going through. So once it gets through the atmosphere, a big parachute will open to slow it down. Once it slows down, the heat shield will fall away. And it's in this canister. That's an inflatable canister. It's about a 100-meter long rope. When it gets fully extended, it will inflate. And this is what Sojourner tested. Sojourner tested this type of landing system. So it's still going very fast. So they fire some rockets to slow it down. And about 50 meters above the surface, they just let it go. And it bounces and rolls and bounces and rolls. Remember, it went 400 million kilometers. It took 7 months to get there. It's very fragile. And this is how it landed. Everything had to work perfectly. So it's counterbalanced, so it will land on its wheels, and then it deflates. So these were sent to Mars to look for water, because scientists believe if water exists, there's a good chance that life exists. And these are solar powered. It has a TV camera, and if you see all of these rocks in this area, this is what scientists believe one time was a huge lake. If we have a lake on Earth and it dries up, we see rocks all at the bottom. That's called sediment. That's why they think this was a big lake bed at one time. So it was on Mars, and it was going around exploring and looking for water. And how it looked for water, this shows it cruising around Mars, but it actually went about 7 meters and stopped. And it was controlled by geologists in Pasadena. Just like you have a computer game, they drove it around with a joystick. It would go about 7 meters, it would stop, it would look around, send a picture back to Earth, the geologist would analyze it and tell it what to do for the next 7 meters. But one thing about Spirit, now Spirit lasted for 5 years. They were only supposed to last for 90 days, but they actually lasted. There was two. One was Spirit, one was our Opportunity, and they landed about 2 weeks apart. But with Spirit had problems. These things are solar powered. And so when something is solar powered, it takes energy from the sun, it converts it to electricity, and they had electric motors on each wheel, and it provided electricity to that motor. That's how it got around. But one of the wheels locked up, and it was a right front wheel. So if you try to push something through the dirt, it's very difficult. So they turned it around and they drove it backwards. But what they created, they actually created a little trough in the surface, which gave them more and more things to study. So it really went well. So it went for about 5 years, and then it got stuck in the sand, like in Florida. We're able to drive our cars on the beach, which is so cool. But if we get off in the loose sand, we're going to get stuck. And that's what happened with Spirit. After 5 years, it got stuck. They used it as a stationary lab for a while, and then it just died because the solar panels couldn't generate enough electricity to keep it charged. This is a cool picture, a sunset from Mars, which I just like to share. So this was Opportunity. Now, Spirit and Opportunity was sent again to Mars to look for water. Spirit lasted for 5 years. Opportunity lasted for 15 years. And it was still going when it stopped. It wasn't a mechanical problem. What happened with Opportunity was they had a huge sandstorm, and people don't understand one of the harsh environments of Mars, besides the radiation and the weather, is also sandstorms. They have huge sandstorms that will engulf the whole planet. And it had a huge sandstorm, and for Opportunity, this is what it would look like on the right. You see, it's all clear. The solar panels are able to absorb energy from the sun. But on the left, this is what happened during the sandstorm. It got covered with sand. It couldn't charge the battery. So after 15 years and about 43 kilometers, it just passed away. So it was only a couple of years ago, I think, that it happened. And we all were kind of hoping that maybe a big windstorm would blow it off and clear it off and it would go again. But it didn't. But it was amazing for those 15 years. Now, this is Curiosity. Now, Curiosity is doing amazing things. Curiosity is nuclear powered, and it weighs about 1,000 kilos. And it's like a great big six-wheeler on Earth. With Spirit and Opportunity, you had to be cautious because they were small. Something might tip them over, and the mission would fail. But with Curiosity, it was nuclear powered. It had this big wheels, and it had a lot of cool things. It had a laser. It has a laser that will shoot a laser at a rock and blow it apart and analyze it. And after it analyzed it, if it liked what it saw, it had a drill. It could drill a hole into a rock, take a sample, and in the back of it had 3 big doors where they could take that sample and analyze it. Now, I want to show you how Curiosity landed as opposed to Spirit and Opportunity. But I want you to think about those 3 things. Do your best, enjoy what you do, and believe in yourself. Doing your best is pretty simple. Anytime you do something, challenge yourself to do your best. Feel good about your effort. It doesn't matter what happens. Feel good about your effort. Do it again. You will get better. And I'm going to prove that to you. The second thing, enjoy everything you do. It's easy to enjoy something you like. The challenge is to enjoy something you may not like just as much. It's 100%. If you approach it the right way, you can enjoy everything. And believe in yourself. This is so important. So few people have this belief in themselves. And the way you get that belief in yourself, I always talk about dreams and goals. If you have a dream, write it down and say, this is my goal. And ask yourself, what steps do I take to achieve it? And make sure you plan small steps. The smaller the step, the easier it is to accomplish. The easier it is to accomplish, the more confidence you get. So you build and you build and you build. And ideally, at some point in your life, you can say, I can do anything. And when you believe that, you'll never have stress. You'll never have pressure. And if you enjoy everything you do, you'll never work. And this should be your life. Everybody has so filled with stress and pressure, but you don't need it. And this is what I do. And I'm no different from you. So I want to show you how this landed on Mars. But I want to prove something to you. I asked you to count down from 10 to 0 on the first launch. To do your best, just see how well you can do. Now I'm going to ask you to do it again. And you're going to see, because you learned, you will do it better. It's the same thing you do. So this is going to be an Atlas rocket. When it counts down, jump in, count down with them, just like you did. When it blasts off, we all jump up and down. Remember, we're making a lot of money. We're at the beach. We're in the sunshine. It's just amazing. And we want to enjoy this as well as every aspect of our life.
T-minus 10.
Okay, jump in and count.
9,
8, 7, 6, 5,
5,
4,
3,
3, 2,
2,
1.
1.
Ignition.
Main engine start.
And lift
0
off.
and lift
So we all
off
jump
of
up and
the
down. We're
Atlas
clapping. We're at the
V
beach. We're
with
catching rays.
Curiosity,
We're having a great
seeking
time.
clues to
It's
the
just such an
planetary puzzle
amazing
about
opportunity.
life on Mars.
The program is in right on time.
So I'm not going to show you how it got there. You know how it got there, but I want to show you how it landed.
Expected.
Same thing when it's going up. Curiosity's had some steering rockets, so it could go through the atmosphere at the perfect angle so it doesn't risk burning up. The same thing, a big parachute opens to slow it down. But when the heat shield falls away, Curiosity has its own propulsion system. It flies around Mars looking for a landing site. That's called a sky crane. It lowers it down. Sky crane flies away. And it's on Mars right now. Now, for those of you who may not have seen this or would like to see it, you can go to the nasa.gov site. And right now they're sending back amazing videos and amazing movies from Mars. And you can see all of that stuff live. So if you have the opportunity to do that, I hope you will.
T-minus 10, T-minus 9, 10, 8, 9, 7, 8, 6, 5,
So I'm not sure what's going
4,
on here.
3, 2, 7, 1, 6.
Okay. A little bit of technical issue there. Okay. So this is Perseverance. Now, Perseverance landed on Mars this year, and it's really an amazing rover. It looks a lot like Curiosity. They're about the same size, and they're both nuclear powered. So there's a lot of similarities. But Perseverance is actually going to Mars to look for life. And it's on the Mars now, and it's sending back amazing videos. So some of the features of this, it's got a super camera that will allow to take micro imager. It's also got a weather station to study the weather on Mars, because this is critical when astronauts or when people go to Mars, how they're going to survive the harsh weather on Mars. So the more we can learn about the weather, the easier it will be to prepare for it. It's got a subsurface radar that allows you to look below the surface and see there. One of the cool fixtures is called MOXIE. So when we go to Mars, Mars's atmosphere is carbon dioxide. We can't breathe that. It would kill us. So what their MOXIE is trying to do is take the oxygen from the carbon dioxide carbon dioxide and convert it to breathing air for astronauts in the future. It's also got a really cool X-ray spectrometer and ultraviolet spectrometer, which allows it to study and see many things. And one of the cool features of this, what it's going to do and what it's already done, it's going to take a sample and it's going to store it. And then they're going to send ships in the future to pick up that sample and bring it back to Earth. So this is what it's doing on Mars right now, and it's really amazing. So if you go to the nasa.gov site, you can see this. It sends back live feed, and it sent back many, many amazing videos. So I like this picture. It's just an artist's conception of what it might be like on Mars. Perseverance traveling around. You see the Earth in the background. Of course, you wouldn't see it because it's so far away, but it's just an artist's conception of what it might be like to be on Mars. So there's this little helicopter. This helicopter is really cool. It's called Ingenuity. Now, it only weighs about 2 kilos, and it's solar panel powered. But one of the things Ingenuity has been able to do, it's been able to fly around Mars. I think they've had 9 successful flights, which has been pretty amazing. So what it will do, it will fly around Mars, and it will look to see what's ahead for Perseverance to study. So they're able to look and scout what's ahead and then direct Perseverance based on what Ingenuity has found. So one of the things I like to talk about when I'm doing the presentation, I really like stars, and a lot of kids love astronomy and they love stars. So I'm an engineer. I'm not really into astronomy so much, but I'm still fascinated by it. And if our planet, if it was completely black on Earth, when we looked at the sky at night, we'd see the star, billions of stars in the sky every night. We don't see them because the light from the Earth filters them out. But if it was completely black on Earth, our sky would be filled with stars. So I want to show you a little movie about what it's like to look at the sky. And this is the sky on Mars. And because there's no light, you see these stars. It just amazes me to think we would look up at the sky and see this many billions of stars every night. So I think this is just fascinating. And they're sending back videos almost every day. And you can see this amazing, amazing sights from Mars, from both Perseverance and Curiosity. So we've actually got 2 functioning rovers on Mars, right? America does. Other countries also have things on Mars, and they're sending back equally. China is sending back amazing videos as well. So a lot is going on, and the future of the space program will involve astronauts going to Mars. Some of you will have this opportunity. That we will see it in your lifetime. There's no doubt in my mind. For this, I like to show this picture because at some time, again, some of you may be on Mars and you may be exploring Mars and you'll see this beautiful sky and all of this majestic around you. So it's in the future. I know Doctor's going to talk a little bit about living on Mars, I believe, but I think it will be probably 20 or 25 years before astronauts actually go to Mars. One of the reasons I think the challenge is it's not to get there, it's to survive there. When you go to Mars, you have to stay 23 months before you come back because of the way the planets are going around the sun. So once you get there, and they're not aligned for another 23 months. So if you go to Mars, you have to stay 23 months, 7 months there, 23 months to live there, 7 months back. So it's over 3 years that you're going to be gone from the Earth if you go to Mars. And Mars is a harsh environment. I don't know if any of you have seen the movie called The Martian. I think The Martian is really a great depiction of what life will be on Mars. If you've seen that movie, one of the things you see is this guy driving around in this truck. Well, that truck exists. That truck is at Kennedy Space Center. It really exists. And one of the things you see in that movie, which you may not be aware of, he's trying to communicate with the spaceship that left him behind. So what he's doing, he's traveling around Mars, and he's actually looking for Sojourner. So he finds Sojourner buried in the sand. He digs it up, and he takes some of the electronics. And that's how he's able to communicate with the spaceship so they can come back and get him. It's a really interesting movie, but you see them growing food there. You see them living in a domed area. There's a lot of things that have to happen before people can survive on Mars for 2 years. So I don't think it's a question of getting there or even getting back. It's how to survive during that period of time. So one of the things, the last thing I like to talk to you about, I've been to 14 countries. It actually amazes me that I've done this. I'm like many of you, basically a civil structural type of engineer working in an engineering department. And all of a sudden I kind of got involved in speaking. And so 6 years ago, I resigned my position at Kennedy Space Center so I could go speaking. And it was amazing. I wanted to go to India for the longest time. I could never get to India. And thanks to Jay and Nikki, I finally got to India, and it was amazing. But I've been to 14 countries doing this around the world. And I speak with kids from 5 years old through adults. And one of the things I get asked, no matter what age, no matter what country, they ask the same question. Hey, Gabe, I'm up in space. I got to go to the bathroom. How do you go to the bathroom in space? So it's a Canadian astronaut. He's been up on the International Space Station. He's going to tell you how you go to the bathroom in space.
When you go to the bathroom on Earth, you're relying on gravity pretty heavily. Imagine if you were halfway done and somebody shut off gravity, it would be a mess. And you'd float off the toilet. So when we designed our space toilet, first it has to have a seatbelt on it to hold you down. And then we decided to separate solids and liquids because they're easier to store that way. So we just have a tube that you pee into, and it has air pulled into the tube. So it's not a big deal. For the women, there's a cup fits up against them. For the guys, it's just like a little funnel. You just pee into this tube, and it goes into a sewage tank. But the solids that come out of your body, that's a harder problem to solve. And it's an important medical one, because on Earth, everything falls on the floor. But in space, it's going to float around. So it'll really make you sick. If you re-ingest something that came out of your body, it will really make you sick. And we can't afford to get that sick. So we designed a toilet that instead of gravity pulling everything into the toilet, it has air flow. There's air pulled down into the toilet. Sort of windy when you're sitting there, but it pulls everything out of your body. Everything that comes out of your body gets pulled down into the toilet by the air. And then in the storage tank, we just expose that to the vacuum of space. So it basically just freeze dries everything. So it kills all the bacteria so that there's no smell. And then we just store it. And then when you have a whole bunch of it stored, we put it in a little unmanned supply ship and we undock it and it burns up in the atmosphere. So the next time you see a beautiful shooting star going across the sky, that's what it might be.
So it's very, very important.
When you
I would like to just talk about that movie a little bit. It's so important. You guys are a little bit older. It's not so bad. But with younger kids, they say, I'm never wishing on a star again. It's gross. It's poop. This is just a comical way of showing you what happens in space. You really can't see that ship. But, you know, we all wish on stars. From the time we were little kids, our whole adult, we wish on a star. So I want you to know your dreams can come true. Wishes can come true. If you see that star, make your wish. Go home, write it down, and say, this is my goal. And ask yourself, what steps do I take to achieve it? And remember those three things. Do your best. Enjoy what you do. Believe in yourself. And that belief in yourself is so critical. Very, very few people have it. That's why they have stress. That's why they have pressure. They do it to themselves. If you can learn to develop that belief in yourself, you'll never have stress. You'll never have pressure. When I was at the Space Center, they said, Gabe, we got something for you to do. Okay, I can do it. No, you don't understand. It's going to be really hard. No, I can do it. You don't understand. It's really, really hard. No, I can do it. They didn't understand if you didn't have that actual, stress and pressure. And I don't want to do that. It's too much. You're complaining. That's what everybody does. You don't need that. You can have fun. It's so simple if you just do those three things. And remember, plan slowly. Take small steps. Don't be in a hurry. The journey is actually more important than the result, because the journey is what's going to build your life. And when you achieve your goal, you're going to have another one. And often when you get there, it's not what you thought. So you're going to do something else. If you had a miserable time getting there, you won't want to do it. But if you had fun getting there, you'll jump into something new. So that's my main measure to you. 3 things: do your best, enjoy what you do, believe in yourself, and your life should be fun. So this concludes my part of the presentation. I'm going to stop sharing. And I will turn it over to the panel, and I will wait to see the doc's presentation. So I don't hear you guys.
Sorry about that. Thank you, Gabe. That truly was a motivational talk. We went from the space shuttle and ISS to our missions to Mars. And your experience and insights of working in KSC and gave all of us a different perspective of what a launch is actually like from KSC. And you're absolutely right. The journey is so much more important than the destination. We learn so much when we're actually going through it than actually reaching the destination. Thank you so much.
Can I just add one thing? I want to
please.
Just piggyback on what you said earlier about failing. I believe you never fail, never, because you always learn. And when you learn, you become a better and wiser person. So you can never, never fail. You always learn. And when you learn, you adapt that learning to the next situation. So you're constantly building your knowledge. So never be afraid not to try something, because you really can't fail.
Yep, absolutely. So I think we can now begin our second talk with Dr. Kiran. Dr. Kiran, the platform is all yours. We're ready when you are. Can you hear us, Dr. Kiran?
Yes, I can hear you. Can you hear me?
Yes, loud and clear.
So, are you able to see my screen as well? Yeah,
yes,
I can see it myself. Yes. So, you can see my presentation, I believe, right now?
Yes, we can see your presentation.
So, thank you for the kind invitation. And first of all, a lot of appreciation to Gabe's talk. It was really excellent, simply superb, where US is going towards landing on Mars with their rovers, getting a lot of information for the mankind. So we are still building our rockets. So before we start, as one of the most important thing, I think most of you know, all of these people from Vikram Sarabhai, Satish Dhawan, Abdul Kalam, and U.R. Rao, these are the stalwarts of the Indian space research where we are today, which was originally formed in the year 1972, where ISRO was, commissioned from the INCOSPAR and Department of Space. And then finally, in the year 2020, May, the private sector was permitted for the participation in the space industry after, building a lot of launch vehicles ranging from SLV to GSLV Mark III. The Indian space program has, as of now, become much more dynamic and efficient, rather to say. And we start our presentation by paying our respects to the stalwarts. So, as you all know, most of you know, so these are the traditional images what you see from Van Hu's flying chair, where Van Hu also had a lot of failures. Tipu Sultan using the rockets against the British, and a lot of scientists ranging from Copernicus to Newton till date, where we use Skolsky's rocket equation to correlates work whatever he has done with the first human Earth orbit mission in 1961, the Werner von Braun for the V2 rocket. So all these are a part of space where we are presently. So what we typically know in India from the space is how to get the maximum services from the satellites. As and when we talk about any space, we keep them in space for unlimited time. That's time where everyone wants, maintaining the orbital velocity, and how to inject the satellites at such high velocity, or multi-space space transportation vehicles, where we try to cut the costs at the cost of rocket weight loss. So there are a lot of materials which play a major role. It's of course my specialty: weight saving, cost reduction, safety and reliability aspect. There's an interplay of many aspects whenever we talk about space. So what we further need to do beyond, where most of us in mankind, ranging even from the US or from any country in the world, what they aspire is to go beyond. You can see here all the planets, the moon, the sun, and the planets Mercury, Venus, all of these things. Most of us want to unravel the hidden secrets what are there And everyone, each and every scientist, whatever we do in our day to day, we aspire to know more and more in depth. And in this field where we are now of space, it has unlimited secrets, and I don't think a lifetime is even enough to understand a bit of it. So, as you know, we have a lot of things in space: debris, extreme temperatures, charged particles, zero gravity, magnetic fields, deep vacuum, radiation hazards. It's an unforgiving space, and it's a great challenge for us to survive. Like, for example, the space station is making amazing things. Even the Chinese space station is doing amazingly good nowadays. The technology has to be developed to address each and every difficulty whenever we go to further planets beyond, and probably one day we are also going to go into future galaxies with the nuclear propulsion techniques which are emerging. And as you see now, some questions which are basic: why do we need to go to space? What do we need to do in space? Who can go to space? Be it doctors, nurses, engineers, scientists, artists, movie teams. Recently there's a movie team which I went up the space station, physicists or botanists. There's no limit of who's supposed to go into space. There's no particular field which is being said, no, this field only needs to be. It was a past. Nowadays, everyone, all fields are wanted in space. So space is now becoming much more multicultural or multidisciplinary, in a simpler word. So going to space was a tough job previously, but nowadays it has become much more easier. And the building these machines on a rampant scale to address the necessity is what we believe is very important as of now. Not only for the satellites, but also for the interplanetary missions. It becomes very important. So, dawn of the space era, as most of you know, October 4th, 1957, Sputnik 1, and then October 4th, where we had the Sputnik 1 launched. Russians did an amazing job at that time. And then USSR competition to cooperation took place with the first man in space on April 12, 1961. A lot of events have taken place. All these stamps on the right hand side depict all of these events, which I don't want to further go into. But after looking at the rovers present day, where the rovers land on the thing and on different planets, I think where are we? We have to also have India for dreams, and we have to get and go for it. So just for your information, I think most of you know it. So the modest beginnings were had where we had the first Nike Apache rocket from the Tumba Equatorial Rocket Launching Station on 21st November 1963. So it was set up at the St. Mary Magdalena Church, which serves as the office for and laboratories. Now it's converted into a space museum. Amazing, you should go and visit the space museum at Turles. It's a fantastic thing. So it's in Kerala, in the capital of Kerala, Thiruvananthapuram. So I think I have a brief video of it. And initially, people used to carry them on the bicycles. You see the sounding rockets being made and then carried over. So this is the 1962 church of Mary Magdalena Church. It's an amazing thing where our country should be amazed of. And this is the first sounding rocket actually, which was on 21st of November, which was shot into the space from Indian soil. And as time progresses, we had a series of sounding rockets from ISRO. From sounding rockets, it went on to launch vehicles, SLV, ASLV, PSLV, GSLV, and GSLV Mark III. An amazing achievement we should be proud of from the point of view of ISRO. And then, as you know, these are the two operational launch vehicles of ISRO, the Polar Satellite Launch Vehicle and the Geostationary Satellite Launch Vehicle. So both of them have their own benefits, and PSLV is also said as the Indian workhorse rocket. So it has seen very good success rates and launch cadence. So as you see the rockets, it's very easy. But for us to understand, it's like a cake, like stacking a cake, but not a cakewalk. So a lot of steps are involved. and ISRO has mastered all these things over the years. What you can see, the rockets here, stacking up the rockets on different stages, carefully. You see the people doing it at Sriharikota, and assembling the rocket, the different, propulsion systems with great care, and finally the fully assembled rocket stands to be on the integration area to be taken further on. So this is a small video. I think most of you might have watched the C-47 launch. So this is a video where the stacked rocket is taken from the integration area, people working towards the launch pad. This is the workhorse, what we have. And then, as Gabe said, you also have the countdown, 7, 6, 5, 4, 3, 2, 1. And then the launch happens of the PSLV. India is proud of our PSLV, which has done a lot of missions, including the Chandrayaan-1. And then the next launch vehicle, what you know very well, is the GSLV launch vehicle, which is a heavier version, which can take heavier launch payloads into the orbit. So most of our launches as of now are typically governed by the government sector, and you typically see the onboard cameras, recording the videos also. And all Indians are proud of our launch vehicles, which take us, much more beyond. And as you all know, there are a lot of launch pads in the US, but in India we have as of now only one launch pad which is operational, accessible to the rocket launches, that is the Sriharikota. And a new launch pad is being developed at Kulashekarapatnam in Tamil Nadu, almost at the tip, which will give us much more access to the polar orbit trajectory, saving a lot of fuel for us. So it means indirectly we'll be getting a lot of payload additionally. So a lot of things happened in this case, and now we are here, the India's new space era. What do we call? With the constitution of the IN-Space, which is directly under the Department of Space, and with the constitution of New Space India Limited, which is also taking care of the launches of ISRO. Yeah, so let's see where IN-Space is going to take us, and NSIL is going to take India to. And this is an organigram which is the uppermost, which is governing the Department of Space, and the Space Commission typically governs the whole thing. So as a result of our new space policy, rather to say in May 2020, we have new entrants into the space industry, and I'm lucky to be part of Skyroot Aerospace. And of course, there are a lot of new rockets being made in India to take India to new heights, leading to further interplanetary missions or reusable launch vehicles or further propulsion systems. Or there's no limit to our thoughts. It's all what we want to do and where we want to take our launch vehicles in India to. So just a briefing about what Skyroot is about. Skyroot is India's leading private space launch company, where we are the first company to sign the first memorandum of understanding with ISRO for the utilization of the facilities of ISRO and also the launch pad. So we are the national award-winning startup founded by former rocket engineers of ISRO, that is Pawan Kumar Chandana and Bharat Taka. We are as of today over 95 plus team members with over 500 years of combined rocket expertise. Hope we get to the launching our rockets Vikram 1, Vikram 2 and Vikram 2 very soon. Vikram 1 is our launch vehicle, which we envisage to launch next year end, and built on a common upgradable architecture. So as I told you, we are the National Startup Award winner for the year 2020. So this is a brief video about what we are aiming to, as most of you are, looking forward to see what Skyroot is doing. So it is envisaged that there are over around 20,000 satellites to be launched in the next 10 years, of which 80% are small satellites. So we intend to cater to these small satellites, buying at Skyroot, offering affordable on-demand launches for small satellites and constellations. Yeah. So this is a brief thing about what we are and where we are doing. So this is a successful test of a solid stage and successful test of a liquid engine, the Raman engine. And we were the first to print 3D printed engines. Yeah. Yeah, we have a lot of expertise in multiple areas ranging from propulsion systems to structures, GNC and avionics and flight systems. So this is a brief corporate video of us. So we hope to be pioneers in launching, democratizing the space sector. Yeah, so this is a brief, talk from my end, and I'll be also open for discussions. So over to you, Arjun.
Thank you, Dr. Kiran. That was very insightful. I hope you can hear me.
Yeah, I can hear you. Yes.
Yeah, that was very insightful, sir. It gave our audience a humble beginnings of how ISRO started out and how the lack of facilities or money did not stop us from exploring the cosmos. It truly was inspiring to see how far we've come right now in the present day. Okay, I think I'd like to open the floor for the mini panel discussion. So I would invite Gabe as well on the platform. That's possible. Yes, wonderful. So we're going to have a mini panel discussion for a few minutes, and then we're going to take in questions from the audience. So my first question is for Dr. Kiran. So in this current scenario of space exploration, we're going through a rapid development throughout the industry, from mission design to reusability. We're getting new things here and there, but not many of us speak about the actual manufacturing process of the rockets. Not many of them focus on it. So from your experience, how is the manufacturing process itself keeping up with the trend? Because we get new technologies, we get 3D printing, we get new ways to manufacture, but it doesn't always catch up. It doesn't always catch up with when they're being implemented, as to say. So how is the manufacturing process keeping up, and how far are we behind in India?
Yeah, so to tell you frankly, okay. So are you able to hear me?
Yeah.
So India has been doing a lot good recently since the new law has come or new policy changes have come. So the manufacturing has taken huge leap. Also in advanced manufacturing technologies, there's a huge support being given by the government, as well as from the point of view of ISRO, where they're allowing us, to test their test our systems over there in their facilities. So 3D printing is one of the technology which has come up way, into the Indian system a lot. All the rocket companies as of now, which are being, coming up in India, are using this technology, including Skyroot. So at Skyroot, we have multi-stage rockets. So we use a composite technology in addition to the technology of advanced manufacturing of 3D printing. So we print our engines, liquid propulsion engines, or even the cryogenic propulsion systems, what we are envisaging for the future by using 3D printing. So of course we face a dearth of manufacturing techniques and their availability. But as of now, this sector is also getting transformed a lot because of the Atmanirbhar Bharat scheme, which is put forward by the government. So a lot of companies have come forward, establishing the manufacturing techniques within the country, indigenously making them. Also, beat even the powder manufacturing, for example, for the 3D printing. As of now, we still import a lot of powders from the US or from the Europe. But there's a lot of work which is going on the current scenario, where all the powders are also they are tending to make them indigenously within the country. So I think this all are going to further shape the manufacturing sector, which will aid the space sector. So space is a combination of multidisciplinary fields, as Gabe was also showing. It's not only from one particular branch of engineering. Without all branches of engineering, be it either computer science or civil, there's nothing. For computer science, we need the softwares, or even the entire hardwares, and then from civil engineers, we need the entire launch pads. Otherwise, who's going to build them? Yeah.
Exactly.
So every stage, we need each and every branch of engineering, ranging from electronics to even to mechatronics or mechanical engineering. Of course, aerospace and aeronautical are a part of it, but all the other branches of engineering are equally important.
Yeah, absolutely.
There's a very nice thing what Gabe also said towards the end, about using the toilet on the space station. Yeah, there was a huge challenge which was put forward by NASA recently. Yeah, about solving the issue of using toilets in space. There's a huge cash award also. I circulated myself these are all engineering challenges, and these all require advanced infrastructure. And India is on the way because of the entry of private players into the system. This speeds up the entire process. As a result, the manufacturing gets to an advanced stage. Finally, it gives us a boost to the space sector. So I think I would also ask Gabe for his comments on this.
Yeah, sure. I'm a huge proponent for commercial companies. Your company is fascinating, and I think what it does, it creates competition. It creates more advancement. It gives more opportunities for people to get involved in the space program. So I'm a huge proponent, and I think your briefing was excellent. I really enjoyed it. I'm a huge proponent of Indian space program. One of the things I do when I speak with kids in India, don't try to come to NASA, stay in India. Try to develop your space program in India. Everybody wants to come to NASA, but for me, and I also say, if you can get involved in the space program within India and get experience and gain knowledge, and if you do want to come to NASA in the future, this experience and knowledge will help you so much. But I think if you get involved in India, you might just stay there. And I think that's important for your country and for everybody in India. I follow the Indian space program very much.
This was one of the most important motivation for me, Gav. When I returned back from Germany to India, I was offered citizenship in Germany for staying back in Germany. And even today, my former colleagues, my former boss and colleagues, they invite me back to come back to Germany. But I say I have to do a lot for my country, and I have to develop a lot for my country. Because I'm in an interdisciplinary field. I was always in an interdisciplinary field of materials, and now I've embarked a new, branch of this one, where I tend to help the space sector by using the materials.
Yeah, I think it's great, and I don't know, I'm sure you've been following some of the commercial launches here in America, where they're taking the average person and sticking them in a spaceship. It's all automated, and they're going up in space and coming back, and they're just sitting there as passengers. So
absolutely.
In fact, I'm ready to go. If they say, Gabe, we got one seat, I'm on the next one. So I don't think I would want to go to Mars. I don't think I want to be gone for 3 years, but I would go to the moon, and I would certainly go to space and just experience that weightlessness and the excitement of the launch.
After the 90-year guy who just recently went to the onboard, so I think before 90, I wish to go on board. I'm also a space enthusiast, so I also like stargazing a lot. So I wish I would have the money to go on one hand, but on the other hand, it becomes so much affordable as possible space tourism concept.
When I was on the Space Center every day, I was actually working in a building right next to the VAB where everything is assembled. So I could go in the VAB and watch them assemble these rockets. It's amazing to see this. I'm sure you have seen it. But for me, as an engineer, not really an aerospace engineer, but more civil structural, it was fascinating. But every day when I went to work and there was a launch, I would bring a little bag with me. And if they say, Gabe, we got one seat, I was packed. I was ready to go.
Yeah, absolutely.
I have another question for Gabe. I was very excited to ask you this one. Did you ever have a moment in your career while working in the Kennedy Space Center where you heard about something, a technology or some research, which seemed too bizarre or too impossible? And it was like when you heard it, it was like, no, that's not going to be there. But it worked anyway, and it caught on. Did you have one of those moments?
Well, you know, I'm a believer that anything is possible. So I think anything that happens is not going to be shocking. But one of the interesting things that happened to me on the Space Center, so my job as a civil structural engineer, if there was a problem, I also did air conditioning. So if there was a problem with the bridge and the bridge didn't work, well, we bring flight hardware onto the Space Center, has to go over a bridge. If the bridge isn't working, it affects the launches. So they say, Gabe, go out to the bridge, find out what's wrong with it. So I also do mechanical systems, air conditioning systems. So they said, Gabe, we want you to go look at this air conditioning system. It's not working. So it was over by the space station processing facility, and I was going around this building. I was looking for this air conditioning, and I found somebody, and they said, oh yeah, you have to go inside the building. There's a Rehoboth room. And I said, what's a Rehoboth room? And they said, well, you go in there and talk to the people. So I went in this building, and there was probably a maybe 10 meter by 10 meter cube, all glass, and inside was filled with sand, and they had these little rovers running around. And so what they were doing in this building, they were testing how to develop the rovers to get around in the Mars sand. And for me, that was amazing, just as part of my job to see something like that. And everywhere on Kennedy Space Center, every room you go into, every building, every hallway, there's pictures of space everywhere you go. So your mind is constantly be taken to these magical places. So no, I'm never surprised by anything. I'm a believer you can do anything. And who knows what the future holds? You know, I think one of the limiting factors, and Dr. Kiran may have verified, is speed. You know, it takes us 7 months to get to Mars. We can't go to Jupiter. Is 10 years. I mean, Pluto is 10 years. You can't put a person in a ship for 10 years and expect them to be functional when they get there. So we need to develop speed to go 1,000 times faster than we are now to be able to reach the end of our solar system and go beyond. But I think it's so fascinating, and it's developing every day and getting more and more opportunities. And with companies like Skyroot and SpaceX, these commercial companies, they are driven in many different ways than the governments, and they'll do more with less. So I think it's fascinating. And for me, I'm a believer that anything is possible.
Coming back to Dr. Kiran, so we're talking about 3D printing of rocket components. There is a certain company in US called Relativity Space where they made the headlines by 3D printing fuel tanks. There was huge components, these huge parts that no one really did before. And everyone was aware of the own 3D printing, but no one thought about 3D printing an entire fuel tank for a rocket. So, do you think this tech will catch on in the future? The way
Absolutely. I strongly believe that it's going to catch on. And what would also catch on is, as you know, time progresses. There are also propellant tanks nowadays. Originally, the propellant tanks were, cryogenic propellant tanks were made out of metal. And nowadays, it came on with metal liners. Now it's the era of linerless propellant tank completely. So they don't use any liners at all. So it's ultra light. So that is one era which is booming fantastically in the US and in the Europe. Recently also the Iran is planning also to take the linerless propellant tanks. And also if you look at the other part completely on the other side of the 3D printing, there are also 3D printing which is coming up in space. That means in space manufacturing.
Yeah.
So for example, you go onto the moon where you land, you can use your 3D printer by sieving the regolith over there, the sand on the moon, and you can build ceramic structures which can be used also partly. You can make composites out of it. You can carry the powder and define the space. For example, just imagine when you go to moon and some part of the rocket or infrastructure is got damaged. You can 3D print the component again back. So that is going to benefit a huge way to the mankind. So with I don't see a change that probably by 2030 we would see a massive change in the entire space era, which would mean that probably we might also start mining with a lot of people going here and forth. So that's one of my vision, which I questioned a guy not recently, quite a few months ago, and I said, he said, "You're crazy, mining on the moon? No, never, it'll never happen." I said, mind my word, by your 60th birthday, this might come true, and I want to talk to you on your 60th birthday.
Yeah, I mean, they're working on it right now, so yeah.
So I think by 2030, I would definitely be optimistic on seeing it on a large scale.
The ability to basically manufacture components on the spot, and like you mentioned, if there's any damage to any component,
a lot of AI is coming into the picture. A lot of robotics is coming into the picture. They're manufacturing with the help of laser-based manufacturing technologies with the robotics, incorporating AI into the system. It's like a boon to the mankind. So there is no branch of science or engineering which is left out by using all these things. So everyone comes and joins the entire ball together.
Yeah, exactly. And I think that basically adds to what you just said. Aerospace is not just from one sector. It involves all domains. So without which it's not even possible. So yeah. Gabe, could you tell us a little bit more about your journey to NASA and your experience as a structural engineer? Maybe like how you got there, because in India it's quite unconventional to actually think of going to an aerospace company when you're a civil engineer. It is improving. Things are thinking very differently, but when students want to work in the aerospace engineering industry, they usually want to be mechanical engineer or an aerospace engineer. They don't really think that design won't come into this, or civil engineer, they really can't connect. So can you tell us more about what your journey was of getting into NASA?
My journey was really interesting. When I talk with schools and I talk with students, I always tell them that I hated school. I did terrible in school. I really hated school. I loved the beach and I loved sports. So when I was a little kid, they dragged me off the beach and they put me in a box and they said, read. And I hated it. I wanted to be outside. I didn't want to be inside. So I really struggled in school. To make it worse, I have a twin sister. She loves school. So, my parents were always saying, why can't you be like your sister? She never causes us problems. All you do is cause us problems. It was really a struggle for me. And I didn't want to go to high school. I just wanted to get away from school, but I had to go to high school. So I basically went to high school just to play sports. We have great sports programs in America. So I'm going to high school. I'm going to play sports and then I'm done. So when I finish high school, I tell everyone my first job was working at McDonald's, flipping burgers and making fries. And I loved it. No homework, no tests, no nothing. Just hanging out with my friends and having a blast, just enjoying flipping burgers and making fries and getting a little money to spend to go to the beach. So I really, really enjoyed it. But I like racing cars. My hobby involves racing cars. And no matter how many burgers I flipped or fries I made, I couldn't generate the income. So for 12 years, I tried many, many different things and nothing works. At the end of 12 years, I said, I have to go to university. So I went to university for 8 years at night. So 20 years after I finished high school, I finished university. And I talk to kids all the time. Look, if I can do it, so can you. I consider myself a burger flipper. I was in the Air Force. I was in the Air Force in Cocoa Beach, and I saw the first shuttle launch. And when I saw that first shuttle launch, I said, I want to get involved somehow in the space program. So when I got out of the Air Force, I got a job at Cape Canaveral Air Force Station, which is adjacent to Kennedy Space Center. And then I was able to move over to Kennedy Space Center and get a job working as a contractor for NASA. And that's kind of my journey. It's really was a lot of fun along the way, but it's always reminded me to be thankful and appreciative. And every day when I mentioned to you earlier, this weekend I'm going to the Space Center for the Lucy mission, and I'm going to be an escort for foreign nationals. So I will be on a bus talking about the program and get out to the launch site, and I'm able to see the launch, from 5 kilometers away. So it's been pretty amazing journey, and I'm so grateful and so thankful, and I love sharing the excitement and the fun and the reality that, hey, if I can do it, anybody can do it. And I really, really appreciate Dr. Kiran's information and his encouragement for people to stay within India and develop your own space program.
Absolutely. Dr. Kiran, you're the head of research and development in one of the most well-known private aerospace companies in the country. So what advice would you give to students regarding the current trends in the industry, locally and internationally? And what advice could you give them in general? I'm pretty sure there's a lot of undergraduates watching this video. I'm pretty sure they'll be watching it in the future as well. So what advice could you give them?
So a major thing I would stress on, the most underlying point is what Gabe said. Do your 100%. Don't do partially. Whenever you do, I look at atoms. Atoms is like normal to me, being an electron microscopist. So I go to the finest nanometer angstrom level to look at the interatomic distances and look at their atoms. The same way on the other side, you have light years where we are now doing in space. So both are extreme conditions where we need to delve deep to understand anything. In life, as Gabe said also, you have to give your 100% or one's 100% to do anything. And in India, because of the opening of the private sector now, there's an enormous amount of interest. I cannot tell you so much of potential exists now where everyone can even become an entrepreneur. An entrepreneur who can do a lot of activities is only built on the point that he or she understands everything to the deepest core possible and aligns it in a proper form. So to all the youngsters, do your 100%, learn, and try to build things rather than buy and use it. Try to build your own things. For example, just ask Gabe what would he do if he does not have a proper a board to work on. He would try to build it rather than going and buying it. Or in a small program where he wants to automate it, he would try. Most of the foreigners, or even in Germany or in Europe or in the US, they have the inbuilt inherent tendency to build when they need something rather than going out looking just to buy it. And we in India have to change this attitude and then try to build up whatever we need. And this is actually the stepping stone to success of the space industry and also of the manufacturing or any other industry, wherever we are going into. And also, we should not also focus on only one thing whenever we are working on. If there is a necessity or at an undergraduate level, I'm talking about at an undergraduate level, not at a higher level. Once you go higher, you need to focus on your work, of course. But at an undergraduate level, an overall understanding of every system is necessary. And that is what is the secret. So a great nuclear scientist who passed away told me, he suggested me not to go into nuclear propulsion, nuclear materials. Long time ago, around 20 years ago. He used to say, people treated me like an untouchable. Yeah, at that time, long ago. And then nowadays, we are talking about nuclear propulsion.
Yeah.
So Gabe just talked about nuclear propulsion in his talk, which is very dear to my heart, to tell you frankly. It's the dream of mine where India one day would make nuclear propulsion a true reality. I don't see that it's long, far away. I see that in the next coming decade or the present decade where we are in, a huge change is going to be happening in the space sector.
Absolutely. Gabe, what advice would you like to give to the students who are hoping into getting into this industry, no matter in which field they are?
No matter in which field they are. 1 second, sorry, Gabe. I just took the word from Arjun, but I would point everyone at Gabe now before Gabe gives his word. Gabe is from civil engineering. Yeah, and in India, Gabe, once upon a time, I don't know what's the current scenario, but once upon a time, people never used to consider civil engineering a good branch of engineering. Yeah, I used to always fight against it. All branches of engineering are equally important. So I think now you should stress upon that point also, Gabe.
Yeah, no,
Over
it's
to
true.
you.
It's all about a team, and no matter what type of engineer you are, at some point you'll be assigned to a design team, and you'll have to work with electrical, civil, structural, mechanical, all of the different disciplines come together to create a finished product. But my advice always is to students: so three things: do your best, enjoy what you do, believe in yourself. It doesn't matter what fields you go into, and always feel good about your accomplishment. If you've done your best, it does not matter the results. Don't get upset. Don't say, I didn't get what I wanted. Do your best. Feel good about your effort. It will help you build that confidence. If it's not what you want, do it again. I promise you, if you've done your best and you do it again, you will get better. And just stay positive and keep doing it till you get what you want. Never give up. Never get down on yourself. You have to be your own best supporter in life. And it's so important to develop that confidence in yourself. The more confidence you have, the easier your life will be. And you get that confidence by going slow. Don't be in a hurry. The journey, the adventure, the opportunity, treat each day with excitement. And at the end of the day, no matter what happens, feel good about your effort. And the next day, do it again. And have fun every day. You will find if you're having fun, you will do so much better and you'll retain it longer. So this is always my thing to kids, because I face kids around the world with so much pressure and so much stress, and they're just not happy because they have such high expectations. And it's fine to have them, but understand, go slow, enjoy the journey. Even when you get there, it may not be what you want. And even if it is, you're going to do something else again. So the journey, learn to develop that daily routine of enjoying everything that you do and build that confidence in yourself. This is so important.
Absolutely. That was a fitting end to our panel discussion. I'd like to ask just one last question before we end the panel discussion. This is a common question to both of you. So, what are you most excited for in the future in the industry?
Go ahead, Doc.
Yeah, we'll start with you.
No, after you give. After you give.
Well, for me, things are evolving very quickly, but at the same time, there's many challenges along the way. So I think that people will definitely be on Mars probably within 20 years, maybe 25. And I think we'll probably be a commercial company more than a government company that goes there, especially within America with our Artemis program. We're going to go to the moon. So we'll be on the moon for many years developing how to go to Mars. I believe commercial companies like Skyroot and SpaceX and some of these companies, they will actually have people on Mars. And it's almost impossible to believe somebody will be on another planet within the next 20 years or so. But I think it's fascinating. And for all of those who aspire to do that, like commercial companies, like Skyroot, you're going to have so many more opportunities. And so I really encourage people, if this is something you want to do, you can do it, and it will happen.
Only small stepping stones, and failures are the stepping stones to future. And that is a clear example of that. You can see today in what SpaceX has been doing. It has gone through the failures, achieved an enormous amount of success, and it's still doing that.
So Doc, never say failure, say learning experience.
Exactly, learning experience.
Yeah. Learning experience. We never fail. We have a learning experience. Make it positive.
Exactly. So this is one of the most important points that everyone have to learn. It's actually going to be the thing. And personally, I feel that, as Gabe was also saying, I want to go on a day to Mars. Probably I'll be able to see that in my lifetime.
Yes, you will. I believe.
I do believe that.
Absolutely. We always said that is the destination, one of the destinations that we have in our space exploration journey. Thank you so much to both of you. It was very inspirational, and it was an honor to have both of you in this event here today. Thank you so much. I'd like to call on Namana back on the platform to give us more information on the future events.
Thank you so much, Arjun. A humongous thanks to the speakers for such a wonderful session. Also, I would like to thank Arjun for amazingly moderating the session. The first three sentences, like, do your best, enjoy what you do, believe in yourself, this just inspired me completely. And I definitely hope that a lot of you are inspired as well. The whole session was just so exciting. When I saw Gabe enjoying the mission countdowns, it remembered me of my midnights where I used to watch the space launches from ISRO, which were telecasted in the DD National. Those moments just ignited my passion towards rocket science, and I think we should all visit back to where it all started so that that big why of ours will keep us going forward. Thank you, Gabe, for giving your insights and views on Space Shuttle and even on the experience of seeing a launch through a 5 kilometer distance with a feel of vibration. Given me a chance to go to Mars with those rovers, I surely wouldn't miss the chance and would also make sure that it's not just a one-way trip.
Yeah.
It seems like today, once again, we had a good amount of launches for the second time on Mars. We even learned that journey is more important than the destination. Thank you for such a wonderful motivation, Gabe. Thank you.
Yeah, my pleasure, my honor.
Dr. Kiran, thanks for covering upon the Indian missions and for also touching upon the future missions of Skyroot Aerospace. It was also very inspiring to know about your interest of staying in India and making it for India. Also, yes, we need to try to be indigenous and try to build on our own stuff, like, because when someone else can do it, and we can also do it. I would like to wish the very best for the future launch of Vikram series. Thank you for being here today with us.
Thank you.
Okay, proceeding further, let me share my screen. I would like to thank our official sponsor, that is GenXSpace. GenXSpace is an edtech company dedicated to creating and providing with high quality all around space education and services for students and institutions. Formed with the key takeaways of SSERD, a space education and outreach NGO, GenXSpace is committed to igniting curiosity and preparing the young generation for the space age to solve significant challenges of our time with the help of space science and technology. We aim to help we aim to educate and guide curious young minds to achieve their space dreams with space institutions, organizations, companies, startups, and professionals. We request you to go and check out the courses provided by GenX Space at www.genx.space. I would also like to thank our official merchandise sponsor, that is DSpace. DSpace is an ISRO official merchandise store. Got plans to buy merchandises? Then visit dspace.com to order your cool set of ISRO merchandises. Tomorrow, we are coming up with a discussion on satellites past, present, and future. And with us, we will have our first speaker as Aravind Ravichandran, who is the Director of Space Strategy at tomorrow.io. And he is also the founder, writer, and podcaster at Terawatt Space. And our second speaker will be Dr. Ayman Ahmed, who is a space imaging team leader at Egyptian Space Agency. Now, coming to the competitions. Today is the last day to submit your work. The link to submit is OP21comp. Please avoid plagiarism and submit before the deadline. And many exciting prizes are waiting on your way. So hurry up and submit your work. At SSERD, we also offer internships on various topics such as astronomy, astrophysics, satellites, propulsion system, space settlement, and space mission design. For more information and for registrations, please visit sscrd.org. I would also like to thank all the audience for joining us today and for asking such interesting and amazing questions. Definitely, this was one of the wonderful sessions that we had. Please join us tomorrow for yet another amazing session. Till then, take care.